Hi everyone, I'm Mark. I'm one of the co-facilitators of TeachMePCB, and I'm trying desperately to show you how to do board, basic board layout. This will be stream try number 5, which is always fun. But the goal of today is to show you how to prepare for board layout. You don't just jump right into it. There's some things that you have to do first. So, with that in mind, I've got a chat window open on this screen. If things aren't working, please let me know. I had an issue with my program monitor, wasn't working, so I really had no idea what I was streaming out onto the internet. That would have allowed me to catch the problem much sooner. It's working now. So with any sort of luck, you guys are seeing this, and we'll go from there. All right, so let's flip over to our PCB view. I'm going to start by opening up the file that I'm going to work with. Hopefully. I mean, I would like to. Come on. I can't open recent. Okay, that's fine. Anyhow, we are just going to go find it then. We're in Rev 2. I usually try to keep things filed by date. So in this case, 2021 is the year, 11's the month, 02's the day, and 1513 is the time in 24-hour notation. Now this is the file I just opened, with the exception that nobody could see what I was doing. So that was unfortunate. Sorry about that. Let me make sure I keep my chat window open in case anybody's out there watching and you see a problem. So here I've got my board layout, and I should probably change it. Well, that's easier on the eyes, but I was wondering if I should change that to white so it matches what you see. I probably should, so it looks a little more like what you are familiar with, and it doesn't look so foreign. All right. So this is our schematic. This is something that you've seen a few times in the course now. It is what's called a hierarchical layout. So rather than putting everything on one page, we put things on different pages. And the reason why I want you to do that should become clear here in a hurry. Because you do see schematics where everything is just lumped in one group. That's called a flat schematic. This is called hierarchical. And what we have when we've got repeating blocks, you just go in and you make the block once. For example, here is our LED, RGB LED block. And we've got the diode, right? This is the RGB LED, and we've got a capacitor. It's just two parts. The LED is D201, and the capacitor is C201. Now, when I go over here, the software is going to automatically increment those for me. So in this block, excuse me, I'll have C201 underscore 1, D201 underscore 1, D201 underscore 2, C201 underscore 2, D301 underscore 3, C301 underscore 3, or 201 underscore 3. Each one has to have a unique reference designator. So each one of those blocks, the software takes care of that for me. I don't have to worry about it. Now you're looking and you're like, it's kind of a mess. It'll make sense in about 5 minutes. So every time there's a repetition on my schematic, so that's my rotary encoders, that's my switches, that's my my diodes, my RGB LEDs. It takes care of that repetition for me. And if I need to make a change to the LED circuit, I only make the change once, right? If I decide this, I don't really need a 10 microfarad, and I don't really need a 10 microfarad, I could put in a 1 microfarad. I'd make that change once, and it propagates throughout the entire schematic. Rotary encoder. You remember when I moved the capacitors to the wrong side of the resistors, right? I move it back once, I fix it once. So if you make a problem, you're going to be making the same problem multiple times. But then when you fix it, you only have to fix it once. It's kind of nice. All right, let's get ready. The first thing I want to do is mess with something called a class. Now, before I can mess with the class, we need to discuss what a net is. Because you've now got all of these weird labels all over the thing. Every set of connected pins is called a net. It's a network. And it says, in this case, the network connects component R301 pin 2 to component R303 pin 2 to component R301.1 pin A. That's a net. They're all connected. And some nets you want to give special properties to. You want them to work a little differently than the others. Like, for example, the 5v0. It's a power net. Maybe I want to be able to know where that is on my board, so maybe I do something like I make that a little bit thicker than the others. I mean, it won't hurt. It'll help it carry current. So all groups of nets that you want to give special properties to, you give a class. Oh, come on. Don't be off screen on me, you booger. I wonder if I can move that down at all. I absolutely cannot. Well, Deep Trace, you failed me again. Okay, well, I can still kind of illustrate it. For each net, you can define the trace width and the clearance to the others, and then you can move all of your parts into that net. So for example, here I created a high-speed data net. You can barely see it on screen. And in there, I moved all of my one-wire and all of my SPI and all of my I2C data in. So all of these nets, since they are going to be relatively fast, I want to give them all, the trace width I don't really care about, but I want to give them plenty of clearance to nearby nets. I was going for a very simple 8 mil space and trace for most of my designs because it'll be relatively cheap to get made overseas, but it's really no problem for manufacturers on half-ounce copper to do nets that are 3 and 3, 3 mils wide, 3 mil spacing, all day, every day. But we're not trying to push process limits here. We're trying to make life easy. So I could go down to 5 without, or definitely go down to 6, maybe to 5 to some manufacturers without the cost starting to go up. But they're completely capable of doing 3 all day, every day. They just don't like to do it. USB is a high-speed net. We have to treat this one as what's called a differential pair. It's got special rules, but also special spacing. You want to give it plenty of clearance to other nets so that the impedance doesn't change. These numbers, here I've just kind of made them up, but you don't really want to do that. You actually want to calculate them with some impedance calculators. Well, we can talk about that later. And those are probably all the ones that we can see. I'm going to make my power nets plenty wide. Not that I need them to carry the currents that we're dealing with, but I want to be able to spot them easily on the board. I'm just going to make them 16. That'll make them stand out from the others. They'll be twice as wide. And in that, I've got my 3v3, my 5v0, and my G&D net. You've got to go through and label every net with something meaningful, because the default is going to be something that's meaningless. I'll just do a quick example here for you. This is going to label this like C102 or 103, or in 102, in 103, something useless and confusing. In 103, right? You're not going to remember what that is. Who would? So go through and label every single one of your nets something useful so that it's easy to identify later. Like here, I know this one is the one-wire signal that goes from LED 3 to LED 4. Let's make it useful. Now, a couple other things before we create our first layout. You want to make sure that there's no errors. So you need to do an electrical rules check. And that's different for everybody's software. I'm sure we're going to have a discussion of what ICAD looks like. But we want to throw errors when there's problems, right? You don't want to move on from here if you do have issues. You want to fix them. So electrical rule check, no errors found. That's brilliant. That's good. Check hierarchy, no errors found. Sweet. So I don't have any electrical rule errors going into my schematic. That's important. So now I'm going to convert to a PCB. ICAD might be different. You might have to open up the PC editor and then, import everything. I'm not entirely sure. And it's putting things on other screens for me. Make PCB from schematic, use schematic rules. That's great. All right, this is pretty typical. It just dumps everything. Some programs are better about this than others. Altium Designer is beautiful. It makes using diff trace painful in comparison. But all I'm going to do now is get everything in order. And now I'm going to show you why it's useful to have these blocks and have everything the way that they are. My encoder circuits. Absolutely everything is going to be 300 something. Right? All of my encoder parts are 300 something. So I can go find all of the components with the 300 prefix and know that they're going to go with an encoder part. There's going to be two sets of them. One's going to have _1, the other is going to have _2. So let's go over here and look at this mess. Well, first of all, let's get rid of those ratlines, shall we? All those connections. So all of these parts now are arranged in, I know it kind of looks like random order. It's not. But we're going to take them and put them in locations that are going to be useful to us. Let me demonstrate. Placement by list. Over back at the schematic, which is here, the light sensor has prefix 101 and its capacitor is also prefix 101. So I can take that capacitor and I can go down and find U101 down here. Those parts are going to need to be put together. And ground, power, it's kind of an unusual spacing for those, but these guys are going to go something like this. Now, I don't want the silkscreen label to be on top, so I'm going to move that over to the side. These parts can now be grouped together. All right, let me take a quick break and go back to my comments to see if there are any. Are you guys able to see stuff? Please let me know. Next up, I can see what's next. All the 500 series. Well, what's 500? We go back over here. 500 is page 5. That's all of my Pico stuff. So if I go through and find all my 500 series and bring them together, I'm not doing any layout yet. I'm just getting set up for layout. None of this is fixed in stone. Hopefully I still have watchers. Yay! Thank you, peoples. I appreciate it. I know this isn't the traditional live stream, but I will check comments. So all I'm doing right now is looking for everything with the 500 prefix. This is why, in my opinion, hierarchical layout is so much easier to use than anything else. Come on, let's get that up there. Okay, so that's all the 500 series. So now I'm going to group all of that. I can move that out of the way. I can arrange that stuff later, but for now, it's all taken care of. What's that down there? Some group symbol? I don't know what that is. Let's ungroup. Will it let me? Let's try that again. Okay, no, there's still that. I don't know what that is. Okay, well, I'll have to figure that out later. All right, let's do diodes, the 200 series. Right, so let's, each one of these is separate 1, 2, 3, 4, 5. So of all of that mess that's up there, of my part layout, I'm just trying to make sense of it. And the first thing I'm doing to make sense of it is just grabbing my parts. There's the diodes, and let's remind myself what's going on with those things. I've got a camera right in the way there. There we go. So on my LEDs, my RGB LEDs, I just need to look for the 200s, and there's just 2 parts. So now I go to the capacitors, and I'm going to bring these things close for now. I'm going to have to move some silk screens and some other stuff around. But as you can tell, all I'm doing now is just looking for part numbers and putting them near each other. Easy, easy, easy. Is what I'm doing making sense so far? I know this is the people that are watching now are a few weeks ahead of the game. So if you do have any questions, I'd be happy to entertain them. I know this is well in advance of the course content for it. I just had a little bit of time to record, and I wanted to make some forward progress. All right. So here's what we have. You want to get the decoupling capacitors as physically close as possible. This is the ground pin. This is the power pin. I'm going to make all of my 5-volt nets red and my ground nets, let's go green. I don't know. Looks like a nice green as far as my options go. And the goal is to get these things as close together as you can. Well, I can't put it right here because there's a silk screen there. So one solution is very simply relocate the silk screen. Get it out of the way, because you don't, they won't, I mean, your manufacturer's not going to put silk screen on the pad anyway. Is there any way to get this closer? There is. I can actually put this on the other side of the PCB. I can rotate it around. Let me see if I can increase that contrast any for you. That worse? That doesn't seem to do anything. Let's just show all layers. There we go. So I could get these even closer. Yeah. Right, by putting them on opposite sides. But that's just kind of overkill for this particular application. But if you're doing really high-speed stuff, sometimes you have to go through that nonsense. But unless you're doing FPGAs, stuff with, nanosecond or less rise times, it doesn't really matter. And what we're doing here doesn't have that. Let's get that back to the right side and get our layers back to contrast. I'm going to try to put everything on one side because it makes assembly simpler and things cheaper. All right, so that's going to be my basic layout for my LEDs and my capacitors. So I'm going to highlight those and I'm going to group them. They will never be separate again. I'm going to do one more and then I'll pivot over and do some other parts for you, okay? Function F10, move this. So I can clean all these up in a little bit. But the basic idea. And now, again, it's real easy to go back and figure out what this belongs to. This is the second hierarchical block of whatever the 200 series stuff is. And I can go back, well, my page 2 or page 3, I forget exactly what page it actually ends up being. But I can go back and I can find stuff super simple, super fast, super easy. That's what you're going for. Electrical engineering is a really, really difficult thing because the signal to noise ratio is so low. There's so many things that you have to keep track of. Making your life simpler in any way, do it. So right now I can do a quick save here. We'll get that started. TeachMePCB, my design, Rev 2, and I kind of want to keep this the same name that I used for the schematic. So let me pull that up. Pico keypad, something or other. Get that open. And I called it. And I'm using version 2.15.10. I need higher resolution displays because I'm blind. Okay, so this will match the schematic that it came from. So if I make any changes, I will have to go back and relink it, but it'll be the same schematic. I really want to know what that is. Okay. Oh well. Let's do the rotary encoders, place by list. So this is R301, RE301. Let's go back and find those. RE301, RE302. All of the 300 series stuff one, two, one. I might not have the best layout yet. That's okay. I am not trying to get the best layout yet. I'm just trying to get these things packed into appropriate groupings so that when I do go do the layout in a minute, I don't have to go hunting for parts. And by doing this too, you know that all of these parts go together. So you don't have to go hunting for them. By getting them all together, you know you're not going to be running traces from here to tarnation. Okay, that's all my rotary encoder resistors. See if there's any capacitors. Oh, there are. So I just grab them and go. 2 goes over here. Okay, so rotary encoders are captured, laid out, and grouped. Get those out of the way. And we can, like I said, we can do advanced, we can do some better layout here in a minute. I'm just trying to make the time valuable to you. Okay, switches. What's involved in a switch? Oh, where am I? I'm not even on the right thing. What am I doing? Single switch. I see it. Click it. Okay, so switch. They're going to be the 400 series. I've got 2 resistors and 1 cap defined. So for each switch, let's lay those out. Okay, so I think at this point we're getting redundant. Let me know in the comments if you want me to keep continuing or if you get the general idea and want me to focus now on proper layout of the parts. I don't want to waste your time. I can always do a jump cut and come back to you. Okay, so there's switch 401. So now I need my resistors in the same fashion. Three, 4. Whoop. I think I grabbed 4 twice. 4, 5, 6, 7, 8, 9, 10. Okay, so that was 402. Now we need 401. Okay, I just got a comment in. There is a delay on my end, but it says it looks like we're good. So now it's time to move on to the other stuff. Okay, so moving on to the other stuff. What's that look like? Let me pull in the capacitors for that, and I will show you. So there's these things called Ratlines, and they show you the connections between the various points on the net. And it's going to be overwhelming at first, right? These switches, I wish they would show the courtyard, but I stole one, and I haven't gone and made my other one yet. But let's look at how these things are all going to go together. You want to arrange them in such a way that you can make connections. We'll move the silk screens in a minute, but you want to minimize the distance between these when you make connections. Have as low an impedance as possible. Okay. So you've got to figure out how these things are going to go together to minimize that. Let me clean up those rat lines in just this area. Right, I could make this connection here pretty easy and fast. I could make this connection pretty easy and fast. But what about soldering these things together? Am I going to be able to do that easily? Is it going to be possible to get these things back apart if I need to? Well, if I make a mistake with this part in the middle, it might be pretty hard to get these two off. So is there a way to lay them out so I can still have everything pretty close together, but I can do it in such a manner that it's easy to repair later? Maybe. You kind of have to play around with it and think about what that's going to look like. And then I need to move the silks. And these might end up being moved later, but I kind of want to get these things in a direction so that I know what everything is, but yeah, it's a little big, but it's fine. So let's see what these things look like once I start running some wires to them. That's a rat line. I don't want a rat line. I want a wire. I want this. Here, let me close this for a minute. So these things now are going to be connected, and those widths that I defined way back in the schematic by class, those are going to get carried over. So here's what I'm thinking. Can I get a soldering iron in from this end? Sure I can. Can I get it in from this end? Sure can. Can I get it over here? Yeah, I could do that, and I can do it here. So by laying them out this way, it's going to be a little easier for me to hand assemble. I could make it smaller if I put those things end on end, but let's not worry about it. There's also this thing called a teardrop. Dip trace doesn't do a great job of doing them, but it kind of increases the distance to the pad. It's not too useful here, but if you have really small traces, it can be a game changer. I'm going to use them on the design, but I'm going to use them later on. So this is an option where I can still get in and get everything repaired. If you think you're pretty confident with it, though, you can save a whole lot of space by moving this over here. There we go. Come on. Don't be that way. Right? If you're pretty good with a soldering iron, can you do that? Maybe. And then we're going to clean up the traces and make the rest of our connections. So now that net is connected. ground is going to be a whole nother thing, so I'm not going to worry about that too much right now. And this is the 3.3 volt power net. Tell you what, I want to be able to identify that one by sight too, so I'm going to do that little guy. Now, we did talk about the power nets having different widths, so if I was to start routing this somewhere, it would look like that. It would be thicker. It's really easy to identify on the board and on the design. But that's pretty much what we're doing. If you want to increase your granularity, you can change your grid size there and get everything lined up all pretty. If you want to add the teardrops, they always help. They rarely hurt. The reason that we have teardrops is for situations like this. That hole isn't going to be perfectly centered in that pad. Things can get offset ever so slightly. Now, if that hole gets drilled to the left too much, and you've got too small an annular ring, well, it can actually end up cutting the copper in the direction of that trace, and you lose net connectivity. So it's always a good idea to have teardrops anywhere that you're going to have a hole drilled. Oh, I made it mad. What did I do? There we go. Do you need them connecting to these? It doesn't hurt, but you should always try to include either a teardrop or a keyhole near the thing. So what's a keyhole? That'll be the next thing. Let me turn these off for a second. So a keyhole, you take a segment and you make it bigger. I don't know. Just make it 50. I don't care. This is just for demonstration purposes. So this is kind of like a sideways keyhole. So now if that via drifts to the left, you still aren't going to break out of that trace or out of that annular ring. That's what I'm talking about with that stuff. So anyhow, so the next thing that you do is figure out how you want all this stuff to look. For each subgroup, you get them together and you group them. On your integrated circuits, well, actually, let's do USB next. Placement by list, because this is a critical one. It's all grouped. Okay. At least I know where to find it. So I'm going to ungroup it now so I can play with it. Here is my TVS diode. Transient voltage suppression diode. This guy's job is to eliminate electrostatic discharge right at the first location that it comes into the board. So we've got to figure out how to route these things, these pins, to these spots. So you're going to move this around and try to eliminate crossovers. You just kind of eyeball it. Okay, so I mean, I could do USB in there. I could run that one. Ground, power. So I could bring that one around. Let's see if I can put some colors on these to make them make a little more sense. Uh-oh. Why did they both turn that color? Oh, because it's changing the whole differential pair. Okay, that's fine. So it's telling me this one goes there and this one goes there. Could I route those? Yeah, differential pairs are a little tricky, but let's see what that looks like. Hey, you can come in. Do you have food? Yeah. Do you mind bringing it? I'm live streaming. Okay, thanks. So these are a little bit close. I don't know if you saw those red things there, but you know, it's not really liking how those things are connected. It's violating some of my design rules, and when I do an error check earlier, I mean, I can't have those things down there. I've got my spacing, my copper to copper clearance is a little too high. So one of the things I could try is I could go back over to the initial schematic. And I can see if I can, oh, no, I'm sorry, the Pico. Where's the Pico? Arg. There it is. So see this little dancing dude right here? These are placed somewhat arbitrarily. I can see if I can get a better placement by flipping these things around, by connecting this one down to USB DM and this one up to USB DP. It's a possibility, but you've got to find a way to route these things. One of the first thing I'm going to do here is, oh, come on, I can't see it. Don't be that way. Grr. Okay. I need to change the class width so that I don't have these things shorting out. Let's try that again. Thanks so much. Looks like dinner's here, so we might have to call this. But that's the whole point. The whole point is, and I guess this is a good spot to stop because I really should do the routing, the careful routing in another video. The first thing that you're going to do is get things organized, get things placed, get things nearby. And then we'll route them in the next one. So, any questions before I go and eat a hot tostada? Ask them now. And I'll give you guys just a second to do that. But that's the goal. Get everything organized. That was the point of this video. I guess I'll summarize it real quick. So we started off, made sure all our nets were labeled. We set up our classes so that we had the, decent trace and space. We did an electrical rule check, make sure that everything was good, that there were no errors. Then we created a schematic, and now we are just organizing, baby. We're just putting stuff together. That's pretty much it. Okay, then I'm going to go end it and eat, and then I've got to go do office hours for another class here in an hour, and then I will see y'all on Discord or in the course. Thank you so much for all your help getting this stream going. It was a headache today, but we got it. We got it. So, all right, everyone, take care. I'll see you next time.